Hello. Today we're going to do a little bit of review stuff to just help you get ready for the final exam. I was planning on doing this last class, but didn't get a chance to since some of the students were taking retests. So just wanted to make sure we had a chance to look at this. So the first thing I wanted to talk about that's not what I was looking at. The first thing I wanted to talk about is just an inclined plane. Okay. So this is just a forces type question, and so we're just looking at what would the acceleration be here. Okay, let's say there's no friction. So we draw our free body diagram. That's our first step. Say mg, we got Fn. Remember, Fn is perpendicular, and those would be our only two forces. Now, mg, hopefully you remember this, can be broken into two parts. Okay, the green part here is going to be mg. It's either sine or cosine and then theta. Okay, and then the blue part, once again, mg and then sine or cosine theta. Remember, if you're drawing a free body diagram for a question, don't have those components on there. But when you're doing it more for yourself or kind of off to the side for yourself, you can include those components. But for the AP exam, you wouldn't want to put it on their official free body diagram if they ask for a free body diagram. Okay, this blue part, remember, this is the part where x does not go with sine and cosine does not go with y. So I have mg sine theta. That is the down the inclined part arrow, down the inclined plane part. And then the green part here is into the inclined plane. Okay? And so my F net, the forces in the y direction, remember we're setting this as my y direction, this as my x direction. Okay, my forces in the y direction cancel out because it's not moving into or out of the inclined plane. Okay, and so my F net is just equal to mg sine theta. Okay, and then I have ma would just equal mg sine theta. M's cancel, A equals G sine theta. Okay. Now let's say I do have friction. Okay. I do have some friction. I would need to go ahead and change this free body diagram and add my friction here. Okay. Now this one, it's going to actually end up being important. You can draw an XY chart. It might help you kind of understand a little bit better. Okay, so let's go ahead and do that. So I have my x and y. And then in my x direction, it's going to look pretty similar. So I still have this mg sine theta. Okay. But now I also have this minus ff. Remember, that should be negative because my acceleration is in this direction. The direction of acceleration, that is the direction I want to set as positive. Okay. And so I'll have that, and then in my y direction, I still have this mg cosine theta, but I also have an fn. Now these also need to be in opposite directions, so I'll make my mg cosine theta negative. Okay, and then I'm going to need to write an equation for my x side and then also for my y side. Okay, so for my x side, you can say, remember, I'm not accelerating into or out of the inclined plane. So the total in my y direction must be what number? Yeah, it has to be 0. Okay, so Fy equals 0. Now you can write out Fn minus mg cosine theta equals 0, or you can skip to the second step where I just add mg cosine to the other side, and I know that Fn must equal mg cosine theta. Right? If I know two things cancel out, then their magnitudes or the number must be the same. Okay. Now, in the x side, this is going to end up being our F net. Okay, so I'm going to take this and put it over here. So I have my F net, and that will just equal mg sine theta minus ff. Okay, so let's go ahead and plug in for F net and ff. So F net is just ma equals mg sine theta minus ff, and my ff is mu fn. Remember, that's a formula on your formula sheet. Okay, so you would be able to look that up. Okay, Now we can go ahead and we need to actually plug in something for this Fn. And so that kind of brings us back to why we needed to do this y side. Okay, we actually solve for Fn right here. Okay, so we're going to plug that in. So it's going to be pretty convoluted, and we'll have a lot of variables, but that's okay. So we have Ma equals mg sine theta minus mu, and then I'm going to do this mg cosine theta. Mg cosine theta. Okay, and you'll notice m cancels out of everything. So A is just equal to g sine theta minus mu g cosine theta. Okay, and so that would be the acceleration with friction. Okay, hopefully this is review-ish for you. I know we haven't really directly talked about forces in a while, but that is something that we've kind of been over a number of times. Now let's go over something maybe a little bit trickier. Let's talk about two-body questions. So let's say I have something like this. Okay, let's make this. Say this is 3 kg. This is 3 kg. This is, let's say, 6 newtons. Okay, and I want to know what will the acceleration equal of this whole system. Okay, now remember there are two ways to set this up. One, we can make it one body, and the second we can make it two body. Okay, now I prefer one body just because it's maybe a little bit easier, but you kind of have to think and understand it a little better. Okay, let's do two body first. Okay, so I'm going to label this block 1, block 2. So let's do block 1. We need to set up an Fnet. So the Fnet for block 1 is just equal to this force here. That's a string connecting these two blocks. So I have a string connecting these two blocks, and I'm pulling with 6 newtons. So that's just going to be T. Okay? And so then I have Ma equals T. Now let's set up for the second one. Okay? The second one is going to have this force tension backwards. Okay? And so here I'll have F net equals 6 minus T. You can also do Ft for tension. So sometimes you'll see T, sometimes you'll see Ft. So either one of those is perfectly fine. So then I have Ma equals 6 minus T. Okay? Now I actually have, I actually have two things I don't know. Right? I don't know the M, I don't know the T. But I also have two equations, so I'll be able to solve it. Okay. So what I want to do, I want to solve for the acceleration. So I'm going to go ahead and solve this one. Well, it's actually already solved. This second equation is already solved for t, so I can go ahead and plug that in over here. So then I have Ma equals 6 minus Ma. Okay. Now these two m's are actually the same. If they were different m's, then I would probably need to label like M1, M2, but they're the same. And so then I just need to solve for A, so I will add this to the other side, Ma, so I have 2Ma equals 6, and then I have 2 times 3A equals 6, so I have 6A equals 6, so A equals 1 meters per second squared, okay? And so that's how you set it up as two-body. For two-body, you need to have two equations, one equation for each object, okay? You set up those, and then you want to solve for the variable. It's usually the connecting force, right? This tension here, that is my connecting force, okay? Solve for that, and then plug it in so you could solve for acceleration. Sometimes they might ask you for that tension, in which case you kind of have to set it up as a two-body, not as a one-body. Okay, now one body is a little bit easier, but you kind of have to understand what's happening. Okay, so for a one body, I imagine this whole thing right here as one object. Now it can get a little tricky because sometimes those objects aren't actually going in the same direction. So I need to think of forces as either helping my acceleration or hurting my acceleration. Okay, so for this example here, I have a total of one outside force, right? These forces here, this tension, okay, is actually a connecting force. So that wouldn't actually count, but I'll include it just to show you that it goes away, okay? So I have my F net, okay, and then I have my 6. Now this one, this part of the tension is actually hurting my acceleration, so I'll subtract that, minus t. But then this part here is helping, so I'll put plus t. And you'll notice right away that these two are just going to cancel out, right? That's the same number either way, okay? And then m, remember, this m needs to be the total m. A equals 6, okay? So the total m is just 6, a equals 6, so I get a equals 1 meters per second squared, okay? So if you set it up as a one body, you need to try to not have any connecting forces. That's usually tension, but you need to include other forces, okay? So it can be a little tricky. Let's try maybe a different one just to kind of review. Let's try something like this. Try something like this, okay? And let's say this is 5 kg and this is 1 kg, okay? So you obviously can set this up as a one body or two body question, but I'm going to go ahead and set it up as a one body question, okay? Oops. So, as a one body, I don't need to include that tension. That's my connecting force, okay? So I just have F net, and then this, we're going to say there's no friction, okay? So it is a smooth surface. Smooth surface is another way of telling you that there's no friction on that surface. So F net just equals, there's only one outside force, right? If I draw a free body diagram for that, I have mg and tension. Then for this one, it's just tension. So I would just have F net equals mg. Now this m right here is got to be that m, okay? This m here needs to be this m here. That's actually a really important thing to remember, okay? It might be a wise idea to maybe even label this m1 and then this one as m2. Or they could already be labeled like that for you in the question, but it's really important to remember those are different. Remember, this m for the F net is the m total equals m1g. So now I just need to plug in. Sorry, I forgot my a. M total a. I'm solving for a here. Okay. So my m total is going to be 6 because it's just 5 plus 1. That's the total of my total mass. 6a equals 1 times 10. So now I have a equals 10 divided by 6 meters per second squared. Okay. Now you could obviously get a decimal number there, but that would be an answer. Okay. Let's try to go one more level. Okay. Let's say I set up something that looked like this. Okay, so this is going to be kind of combining everything that we've talked about so far, right? We talked about our inclined plane. We talked about two body, okay? And let's say I'm trying to find my acceleration, okay? Let's go ahead and make this, let's say this will be m1 and this is just m2, okay? So m1 and m2. So once again, remember we don't need to worry about that tension as I'm setting up as a one body question, okay? But let's go ahead and draw a free body diagram for both of these. So I have mg, m1g, and then here this is m2g. I have Fn here, and then I'm going to need to do what to this force here? I need to break it into components, right? So I have this part. And I'm also going to have this part. Okay, so my blue part here is going to be m2g, and that one's going to be sine theta, right? This is going to be my sine. Okay, and then I have my green part here is going to be m2g cosine theta. Okay, now only this part would be contributing to the acceleration, right? This green part here, that is just going to cancel out with Fn. Okay, now this could end up being important. This mg cosine theta could end up being important if I had friction. Okay, and so let's go ahead and set up our F net. Okay, So my F net is going to equal, well, here's the tricky part. We don't actually know which part I'm accelerating, okay? Because so far I haven't told you. Let's say that this part here accelerates. So it's going to accelerate down, so we'll make this part positive, okay? So m1g, that's going to be positive, and then I'm going to subtract m2g sine theta, okay? And then my F net is just m1 plus m2 a equals m1g minus m2g sine theta, okay? And then just to solve for a, it'd just be a equals m1g minus m2g sine theta, all divided by m1 plus m2, okay? Now, obviously, you can also set this up as a two-body, so you'd need to create an equation for this, and then also an equation for this inclined plane part, okay? For that, you would need to include the tension. For me, I think one body can be a little bit easier, just a little bit more natural to kind of how you're setting that up. Okay, so what would this look like? Same exact question, but let's say we have friction, okay? Let's say it's still accelerating down, so M1 is a little bigger than M2. It's still accelerating down, but now we have friction, okay? So now we need to add an extra force here, which is FF, okay? So for that, what I'm going to need to do, it's going to be pretty similar. So I have F net equals m1g. That's the only force that's contributing to my acceleration, right? Both my FF and this right here, those are both going to be taking away, not that one, sorry. Both that and this m2g sine theta, both of those are going to be subtracting from my acceleration, okay? So I will do subtract FF, that one was pretty easy, and then also subtract m2g sine theta, okay? I know it can be a little tricky with sort of so many different variables, but it's really just kind of taking all the different pieces that you know and putting them together, okay? So remember my F net is m1 plus m2a equals m1g minus, remember the formula for FF is mu Fn minus m2g sine theta, okay? And then what I'm going to need to do is I need to plug in for FF. So we got to scroll up. What was FF equal to? Well, we found earlier that Fn. What is Fn equal to, right? Fn is equal to that m2g cosine theta, okay? We know that in the y direction it's not going into or out of the inclined plane. So we know Fn, I keep making that same mistake, Fn is equal to m2g cosine theta. Okay, so we'll plug that in. So I have m1 plus m2 a equals m1g minus mu, and then I have mg cosine theta. Remember, this is m2g cosine theta minus m2g sine theta. Okay, and then I would divide everything by this m1 plus m2, so divide all this by m1 plus m2, and that would give me sort of my acceleration. Now, there may be some different ways you could simplify this, but this is an answer that is, I think, good enough for AP. One thing also to remember is that in all reality, it's the setup that's most important. So what you really want to strive for is being able to do the setup and getting that setup. And don't waste all your time doing a lot of algebra. Sometimes you can get into tricky questions. They're asking lots of algebra part. Come back and do that later, okay? Focus on other things first. Okay, one other thing I would like to go over is minimum speed. So let's say I have something like this, okay? And I have this block, okay? It's moving along, and it's going to go around this loop, okay? So this is an entirely new train of thought. And I want to know what's the slowest velocity it needs to have. I'm not actually going to draw it that way. But what is the slowest velocity it can go at the top of the loop? Okay? And so this is really saying, what's the speed that it's actually going to continue moving in this circle? And then what would be the speed that it actually just kind of falls off, right? And just falls. Okay? So I'm looking for a minimum speed. And so anytime you're seeing a circle and you have a minimum speed, there's a particular way you need to do this. Okay? And the way you need to do that is using Fnet, but you want to use centripetal. Okay? So instead of using the normal Fnet, we're going in a circle, so you need to use a centripetal Fnet. Okay? So first thing for forces, I need to draw a free body diagram. So I have mg down, and I also actually have Fn down, right? Since it's on the bottom side of something, that will be pointing down. Okay, so I have Fn plus mg, and then let's go ahead and plug in for Fnet. So I have mv squared. Remember, that's my formula. You can find that on your formula sheet for the centripetal Fnet. And then I have Fn plus mg. Okay, now the question is, I want to make my velocity as small as possible. Okay, I can't change m, I can't change r, I can't change g. So there's only one thing that I can change that could potentially make that velocity smaller. So the thing I'm trying to change is my Fn. Okay, the smaller the Fn is, the lower the velocity. Or another way to think about it is, the faster you go, the stronger the track needs to be able to hold that block going in that circle. Okay? If the track is too strong or too weak, right, then the block would break that track and fall off. Okay? So in the opposite way, if I want to go slower, then I want to make Fn as small as possible. Okay? Now the smallest possible value for Fn is just 0. Okay? So when I'm looking for a minimum speed of going in a loop at the top, okay? Now remember, the point that you're most likely to fall off if you're going too slow would be at the top, right? So the minimum speed at the top would just be when Fn equals 0, okay? And so I just have mv squared over r equals mg, m's cancel, and then I can go ahead and solve for my velocity. So I have rg equals v squared, so v equals root rg. Okay, so I have v equals root rg. Now, let's take this one step further. So let's say I have a hill, something like this, okay? And then I have my block at the top here. This is still the same radius. Okay, I want to know what is the minimum height. Okay, what's the minimum height that I need to have in order that I'll complete this loop? So in order to complete the loop, I need to be going at least this minimum speed at that point here. So at this point. Okay, and so for this one, I already know the velocity here equals root rg. Okay, I know the velocity there equals that. Okay, and so the question is, how would you set this up? Okay, I need to know a minimum height. I know a velocity that I have to have at a certain point, and I need to know how high do I need to be. Okay, so this is how high from the floor, from this bottom point. And so the best way to set this up, let's think through this, kinematics. Well, I don't have any time, so that would be pretty tricky, okay? Forces, that would be pretty tricky, because calculating a force here all the way down this, that would be pretty tricky to try to figure out this. They don't tell me an angle here, so that would be really hard to figure out, right? And in fact, impossible without an angle, okay? So I don't know anything about forces. Well, energy. Okay, maybe energy is a possibility. Remember, that's a good go-to. Momentum. Momentum doesn't make sense because we don't have a collision. Okay? So let's try energy. Okay? Now, where would be my 2 points? What would be my initial point? Yeah, I'd want to have this as my initial point, and then where would my final point be? Yeah, the top of that. Okay, so I have EI equals EF. What type of energy do I have at the beginning? Well, this is going to be from rest. So I'm just going to have PEG. And then at the end, I'm above the ground, but I also have to be moving. So I have KE plus PEG. Okay, so I have MGH equals 1/2 MV squared plus MGH. All the M's cancel, so I'm left with GH. Remember, this is what I'm trying to solve for, that H right there, equals 1/2. Then this is going to be root RG squared plus G times H. Now this H here has to be 2R because that's the height of my spot there, okay? So I'll go ahead, I have GH equals 1/2 RG plus 2 RG. These R and this R are the same thing, okay? The G cancels out of everything, so I'm left with H equals 1/2 R plus 2R, which equals, what is that, 5R over 2, okay? And so that would be the answer there, okay? So this is just hopefully a little bit of review to kind of help maybe jog your memory for some different things, and kind of help you out a little bit on maybe how these questions will go on the FRQ, okay? Remember, if you have any questions, send me an email, and let me know if there's something that I can help clarify, okay? Thanks so much.